Hi. In this recording, what I want to do is talk about the idea of average and some of the issues that are associated with the concept of average in statistics. Basically, average is meant to mean typical. And one of my students pointed this out to me. The typical family is said to have 2.5 children. I don't know if that's true anymore, but that's what's been said in the past. And if you look at The Simpsons, actually, they are the typical family because they have two children, Bart and Maggie, and of course, Bart and Lisa. And then Maggie is sort of like a half a kid because, I don't know, she's small and she doesn't really say much. Okay, so what do we mean by average? Typically, when people say average, they mean the arithmetic average or the mean. And to determine the mean, we take the total number of values and divide it by the number of observations. But there are other types of averages that people use. For example, median, which is the value at which half of the observations are higher and half lower. This can be helpful when you have a group of values where some of them are maybe scattered toward the high and others scattered toward the low end of the range where they might skew the data a little bit. And sometimes average just means typical, like what can you typically expect? And this could be the mode, the value with the highest number of observations. So to determine the mean, you basically take the total values and you divide it by the number of observations. And we'll look at an example of this. To do the median, what you're going to do is you're going to count the values and take that value at which half are above and half are below that value, if it's an odd number. If it's an even number, you're going to take the two values in the middle and average them. And then finally, the mode, you just look at the value with the highest number of observations. So let's look at an example. And this is from the book, but let's just look at how to do this. So we have mean, median, and mode for the following. We have a different number of people for each set of observations, and we have the salary that those people get. And what we want to do is figure out how to do each. Now, to determine the mean, what we're going to do is we're going to multiply 1 by 95,000, add that to 2 times 85,000, add that to 1 times 70,000, add that to 3 times 40,000, add it to 1 times 30,000, add it to 2 times 20,000, and then add it to 5 times 15,000. And then we add up all those values. We take that number and we divide it by the number of observations, which is 3, 4, and 3 is 7, 8, and 2 is 10, and 5 is 15. And so we add up what we multiplied, we divide it by 15, and we get the number. And we'll look at that number in just a second. I'm going to give you time to pause and do this on your own. All right. To determine the median, what we're going to do is, we said there were 15, and so there should be 7 values below and 7 values above. And so 5 and 2 is 7. It looks like this one. $30,000 is in the middle, and if we look above, there's 5 and 2 is 7. So there's 7 above and 7 below. So the median is going to be 30,000. Half the observations are above 30,000, half are below. And finally, the mode is the one with the greatest number, which is $15,000. Okay, so the modal point is 15,000. So the mean, let's go to the next slide. Oh, actually, before we go to the next slide, I'm going to pause for a second in case you want to figure out the mean yourself. Okay, and again, the mean is figured out by multiplying the number of observations times the salary, adding all of those numbers up, and then dividing it by 15. Okay, which is the total number of observations. All right, I paused so you could do that. So hopefully you paused, you did it, you've got a number, and let's see if it's the correct number. If you got $40,000, that is the mean. $30,000 is the median, and $15,000 is the mode in this particular example. Now, this can be a huge or significant anyway, in terms of how we interpret this information. If you're trying to get a pay raise, obviously using the mode and saying that the average or the typical person makes $15,000, I deserve more than that. Actually, no. You want to use the mean, because the mean says this is what the average person makes. I deserve to make more, and so you want to go with the mean because that's what the amount is. Your boss or the person you're asking might say, well, wait a minute, the average person actually makes $15,000 because more people make $15,000 than do not. All right. It depends on what you're doing. Obviously, in terms of arguing, you're going to use different numbers, but it depends on what you mean by the picture. The mean may be a little bit high in this particular case because it's taking into account just a couple people who make really high salaries, and the mode may be a little bit low because that could be entry-level people, and so the median might give a better picture of what the typical person makes. All right. In terms of average, the other thing that we need to look at is dispersion and distribution. And this could be really helpful information. For example, there was a time when we would get these evaluations that were nationally normed against evaluations that were done by everybody. So we'd have different categories, our students would fill them out, and they say this is what the average is for you, and this is what the average is for everybody in the country. And it was helpful to know that information. And sometimes we were given both the mean and the median, so that we could look at that. Another thing that happened on evaluations is sometimes we would get numbers related to the dispersion and distribution. That is, how widely do the answers vary? Do people particularly agree on this level of evaluation, or do they fall all over the scale? And it could kind of help you figure out how to make adjustments. So the range, when we're looking at a set of evaluations, is the difference between the highest and the lowest value. So, for example, if we look at this, the range is from 95,000 to 15,000, okay, or a range of 80,000. The dispersion is how the data are distributed within the range. All right, and we'll notice that the data tend to be distributed toward the low end of the range. Now, when you have a lot of numbers, what measures the dispersion is the variance and the standard deviation. Now, I'm going to explain to you basically what these are because your textbook does, and realize all you need to know is the importance of the variance and the standard deviation, which is they tell you how widely dispersed the information is. So, here is an ugly, ugly looking equation, right? Well, I don't know. Some people might find it beautiful. Mathematicians, for example. But all this says is that the variance, and by the way, there's a mistake in this slide, which I'm going to correct actually right now. I bet you've never seen anyone edit a PowerPoint right in the middle of a PowerPoint. The variance is, sorry, so let's go back to this. You can see I'm recording this just as I do it because I had to change this. The variance is the sum of each individual observation minus mu, which is the mean, squared. Okay, it looks like it says times 2, but it's in fact squared over the number of observations. So we take each individual observation, we subtract it from the mean, we square it, and that's going to be the variance. That tells us how far the data range away from the mean. Mu is the mean, and n is the number of observations. The standard deviation, which is sigma here, is the square root of the variance. And so to determine the standard deviation, what you do is you take the variance and get the square root. Now the bottom line to all of this is, take statistics if you want to learn how to do this. But in general, what you want to do here is know that the larger the standard deviation, the more widely dispersed the data is. The smaller the standard deviation, the less widely dispersed the data is. Now, the good news is that you don't have to know this. Just you need to know what it means. And so, again, standard deviation measures dispersion. The higher the standard deviation, the higher the dispersion. Distribution deals with how the data are clustered. Generally, when we're looking at data, we assume something called standard normal distribution, which is also referred to as the bell curve. And I'll show you an example in just a second. The data are clustered around a mode with fewer observations as you reach the extremes of the range. Okay, and the mode, the median, and the mean are all the same. So here is standard normal distribution. The mean in this case is indicated by the x. one standard deviation, two standard deviation, three standard deviations below the mean. The idea is if you have data that lies beyond two standard deviations from the mean, it's said to be significantly different. That is, at a 95% confidence level, we know that it differs from the average, that it's outside of the average. So if my evaluations, for example, are two standard deviations above or below the mean for nationally normed people's valuations, it means that I'm significantly better or significantly worse than the national average. Okay, the rest of it is seen to fall within the average. So standard normal distribution assumes mean, median, and mode are clustered right in the middle, and the observations get fewer as you get away from the mean, median, and mode. The other kind of distribution is bimodal distribution. Actually, there are many different kinds. This is bimodal distribution, where you can see that there are in fact two modes that are at extremes. And this is important because, let's say you're going to market something and you look at a society, and the society appears to be making about middle class income, and you assume it's standard normal distribution, and so you market, say, a car that's meant for middle class income. Then you come to find out that there's an extreme of rich and an extreme of poor and very little middle class. What's going to happen is, because the distribution is bimodal, you'll be shooting for the wrong market. You should be marketing bicycles or Mercedes, and you're marketing Honda Accords, right? So looking at the distribution is very important in terms of getting a good profile of your population. All right, in the next video, what I'll talk about is how to work with graphs and how to interpret those, and also a little bit about percentages, and that will finish off chapter 12.